Now let us start with the next non-traditional machining process, that is abrasive jet machining, is AJM. So you can see here in the diagram, this is the nozzle tip, this is nozzle tip, this is your workpiece, and through this nozzle the high speed air along with the abrasive particles are moving, and they are impinging on this work surface and causing the removal of the material from the workpiece. Okay, so in AJM, the material removal takes place because of impingement of the fine abrasive particles onto the work surface, and the particles are moving with the speed of air or gas stream or jet. The typical size of these abrasive grains is around 25 microns, and the air discharges at the pressure of several atmosphere. So let us see the mechanics of removal in the AJM. Okay, so here when these abrasive particles are moving with very high velocity and they are impinges on the work surface, right, the tiny and brittle fracture is causing, and the flowing air is carrying away this dislodged chip or the wear particle of the workpiece. So it is quite obvious that the process is more suitable for the brittle and fragile work material, and the material removed rate because of this chipping can be given as this xz into d cube into v to the power 3 by 2 into rho divided by 12h to the power 3 by 4, where x is a constant, z is a number of abrasive particles making impact per unit time, v is the velocity with which the abrasives are moving, rho is the density of abrasive material, h is the hardness of material or flow stress of workpiece material. Okay, so this is the MRR in the abrasive jet machining. Okay, you can see. Now let us look at the process parameters. In that, we'll have the abrasive first. So there are mainly two abrasives which are used in this AJM, which is Al2O3, that is aluminum oxide, and SiC, that is silicon carbide, which are available in the range of 10 to 50 micron. And when we are using the abrasive one time, we cannot reuse them as their cutting capacity is goes on decreasing. Okay, so how these abrasives are uh, having impact on these Q, that is MRR. So as we are goes on increasing the mass flow rate of these abrasives, definitely the material removal rate in AJM is goes on increasing. See here, the abrasive mass flow rate as increases, MRR also goes on increasing. The next process parameter is the mixing ratio. So what is mixing ratio? This is the mass fraction of the abrasive present in the jet is known as mixing ratio. That is how much actually the abrasive grains are present in the jet of or stream of your gas, okay, or air. So as see as MRR as mixing ratio increases, it is goes on increasing, MRR goes on increasing, but after some time it is decreasing or it is dropping. Okay, next process parameter is the gas. So the in AJM unit, normally the operating pressure is of 0.2 megapascal. Okay, now if you look at the nozzles which are used in this AJM, so see actually these nozzles are continually in contact with these abrasive grains which are flowing with very high speed. So there are chances of having the wear and tear of this nozzle material also. So for that, it should be hard enough to avoid the significant wear of the tool itself or nozzle itself because of the abrasive grains. So in AJM normally tungsten carbide and sapphires are used, but sapphire is very costly. Okay, so here their cross section area for the orifice of these nozzles are ranging from 0.05 millimeter square up to 0.2 millimeter square, and the cross section may be either circular or rectangular. Okay, so how this nozzle tip distance is governing your MRR, you can see here. So when you increase the nozzle tip distance, the velocity of abrasive particles impinging on the work surface increases, because their acceleration goes on increases when they leave the nozzle. Okay, so because of that you will see there is a rise in MRR. So why their MRR first increase as we increase the nozzle tip distance? So because the velocity of abrasive particles increases, and due to why this velocity increases, due to their acceleration goes on increase after they leave the nozzle tip, and after some time it goes on decreasing. Why? When you are increasing this nozzle tip distance, what will happen? So after a certain time, the on that jet on that jet of this abrasive, the atmospheric drag is going to act, and because of that the MRR is goes on decreasing. So that is the thing. What is happening? The nozzle tip distance and in MRR, initially because of the velocity of abrasive, the MRR goes on increasing, and after that on that jet atmospheric drag is acting. That's why MRR goes on increasing. Please remember this. Let us see the material applications of abrasive jet machining. Of course, hard and brittle materials can be machined with this AJM. Alloys and non-metallic materials like germanium, silicon, glass, etc. can be machined. What are the job application of AJM? We can do drilling, cutting, deburring, etching or cleaning of the workpieces. And the limitation of this process is very low material removal rate, around 15 mm per minute. So this is the discussion of the abrasive jet machining. Let us start with the uh, next very nearer process to the AGM, that is water jet machining. So you can see here, this is the nozzle, and in this nozzle the high pressure water is flowing. Around pressure is very high, around 1500 to 4000 megapascal. Okay, and this is the jet of, see, this is the jet of water. Previous case there was a jet of abrasive. Now here the jet of water coming out of this nozzle tip or tool tip. This is the workpiece. So what is happening here? So when the high pressure water is passing through this converging nozzle, so this is a converging nozzle, so definitely this pressure energy get converted into velocity energy, and water will come out from this nozzle with very high velocity. When this high velocity water jet is impinging on the this work surface, okay, so there is an impact on the work surface, and this continuous impact load will cause or produce the deformation or fracture onto the work, work surface. So the mechanism by which the material removal takes place in this water jet machining is the plastic deformation as well as the fracturing of the workpiece. It is also known as the etching process. Please see, this is also known as the etching process. So the mechanics, if you talk about the mechanics of this water jet machining, you can say plastic deformation and fracturing. Now to withstand for a high pressure of water, the nozzle or this nozzle or this tool material is made up of the tungsten carbide WC. Okay, here the wear ratio is infinity, since there is no wear and tear of the nozzle. That is, wear ratio is what? Volume of material removed divided by volume of tool worn out. So tool worn out is 0, to definitely something divided by 0 is infinity. So wear ratio is infinity. And look at the advantages of this water jet machining. So it is used for soft materials like rubber. Okay, so only limitation you can say that you cannot use for the hard workpieces. So see here, this is a limitation of water jet machining. But to overcome this limitation, if you add some abrasive particle into this water, right, so that these abrasive particles also carrying out from the nozzle tip with very high velocity. Yes or no? So when these high velocity abrasives are impinging on the hard workpiece, it is possible to produce the plastic deformation in the hard workpiece also. Yes or no? So what was the limitation here? We cannot use this water jet for the hard workpiece material, but to overcome that limitation, what we did, we added the abrasive particles. And when these abrasive particles are also moving with this high speed velocity of this water, they are also causing the plastic deformation in the hard workpiece, and we can able to machine the hard work pieces by using this process. So the fracturing and chip formation takes place here. This is, or this process is known as the abrasive water jet machining. Now initially what we see the water jet machining, but we have added the abrasive for the machining of the hard work pieces. So this is known as the abrasive water jet machining, AWJM. Understood? So in this video, friends, we learn about the abrasive jet machining, what is mechanics of abrasive jet machining. So what is mechanics of abrasive jet machining? The high velocity abrasive grains are impinging on the work surface, causing the tiny orbital fracture, and the carrying gas or air is taking out the dislodged or the small chips from the workpiece. At the same time, we learned about this water jet machining. Here water is causing the plastic deformation and fracturing the work surface with a high speed water jet. Okay, which can be used only for the soft materials like rubber. Limitation of this water jet machining was it cannot be used for the hard workpiece material. So we added here the abrasive grains, so that now they can be used for the hard workpiece material also, and the process is now known as abrasive water jet machining. Okay, thank you so much.